we have. So let's do this one. So notice we've had an addition to the problem. This is not in standard form. They want us to put it in standard form. You can do either of those two methods we just talked about. You can do negative b over 2a to find your vertex, and then you can plug it back in and write down the standard form, or you can use completing the square. I'm going to do that one. That's the more standard way to do it. Okay, so we pull out anything in front of the x squared, which would make this a negative 2 here. And I'm just going to scoot that 3 over because it doesn't need to be messed with. We take the number in front of x, which is negative 2, and divide it by 2, gives us negative 1, and we square that, which gives us 1. Okay, I'm going to go back up here and add a 1 here. Notice that I've actually, if I distributed that, I actually negative 2 times 1 is negative 2. So over here I'm going to put a plus 2 to balance that out. So now I have negative 2 times x minus 1. I know it's a minus 1 because of this sign here. And then plus 5. So my standard form would be f of x equals negative 2 times x minus 1 squared plus 5. And then we go through all of those other steps that are there. We need to find the x intercepts, which is up to you whether you want to do that using the standard form you just created or the other. If we use the standard form we just created, remember x intercepts, we put 0 for f of x, and we solve. So I would subtract 5 from both sides. I get negative 5 equals negative 2. Times x minus 1 squared, and we divide both sides by negative 2. I get 5 halves equals x minus 1 squared. Okay. Our next step would be to take the square root to remove that radical, and we put plus or minus, or not the radical, but the squared, put plus or minus. We're now down to not enough room to finish the problem for sure. Plus or minus the square root of 5 halves is equal to x plus, or excuse me, minus 1. And we would add 1 to both sides to solve it. So my x intercepts are at 1 plus the square root of 5 halves, 0, and 1 minus the square root of 5 halves, 0. Now, this is not simplified. You can't have a root in the bottom of a fraction, but I'm trying to save time here, so I apologize for that. What we would do to simplify is multiply by root 2, and we'd actually get the square root of 10 over 2. Our y-intercepts, we put 0 in for x, and what do we get for y? We get 0, 3. Find the domain. Again, domain is negative infinity to infinity. We find the range. Well, for the range, we're going to want to know where our vertex is and whether this opens up or down. We decided that our vertex, based on our little formula here, our vertex should be at positive 1, 5. Okay. It's going to open up or down. There's a negative in front, which means it's going to open down. And we know we have the y-intercept right there. Guess I kind of did this one backwards. I was supposed to graph it first. The range then, our y values, notice, are going downward from here. So our highest y value is the one at the vertex, which is 5. Okay, so we go from negative infinity to 5 for our range. The intervals of decreasing, it decreases for x values from the vertex to the right. So from 1 to infinity, it's decreasing. It's increasing from negative infinity to 1. What is the vertex? We found that that is at 1, 5. Is the vertex a maximum or a minimum? It's the top, so it's a maximum. And what is the axis of symmetry? The axis of symmetry is always x equals the x part of our vertex, which was 1. Okay, so here is a long, drawn-out problem. We wrote it in standard form by completing the squares.